Hi, I am Bhumika.S from Computer Science and Engineering Department of Bangalore Institute of Technology, currently studying in third semester A section, subject Digital Design and Computer Organization, which is handled by Dr. Bhumika.S ma'am of Computer Science Department. Today, my topic is about explanation of XOR circuit with all three different model using Verilog. Brief overview of XOR gate functionality. The XOR exclusive OR gate returns I output with one of two I inputs, but not with both I inputs or both low inputs. For example, if both the inputs are binary 0 or 1, it will return the output as 0. Similarly, if one input is binary, 1 and another is binary 0, the output will be 1, which is I. The operation for XOR gate is denoted by encircled plus symbol. XOR operation is widely used in digital circuits. The algebraic output expression of XOR gate is Y is equal to A naught B, and the pictorial symbol representation of two input XOR gate is here. And the truth table, where A and B are the two inputs and Q is the output. If we give 0 as two inputs, we receive 0 as the output. If we take 0 and 1, we get 1 as the output. If we take 1 and 0, we get 1 as output. And if we take both the inputs as 1, we get the output 0. Importance in digital circuits and application. The exclusive or XOR gate holds significant importance in digital circuits due to its unique functionality, and it finds various applications in electronic systems. Here are some key reasons for importance of the XOR gate in digital circuits, along with specific application. The first one is binary addition and subtraction. XOR gate are fundamental components in binary addition circuits. They are used to calculate the sum of individual bits in binary addition. XOR gates, in conjunction with AND and OR gates, are also employed in subtractors to perform binary subtraction, parity generation, and error detection. XOR gates are commonly used in generating parity bits for error detection and correction in communication systems. In systems with even or odd parity, XOR gates help determine the parity bit based on the input data, allowing for the detection of single bit error. Toggle flip-flops and frequency division. XOR gates are used to create toggle flip-flops, enabling a circuit to change its state toggle with each pulse. XOR gates are employed in frequency division circuits, where they act as phase detectors to create frequency dividers. Digital encryption and cryptography. XOR operations are fundamental in various cryptographic algorithms. Encrypting a message with secret key often involves XORing the message with corresponding key bits. XOR-based operations contribute to the security and confidentiality of digital data in encryption process. Fifth one, comparators and equality checking. XOR gates are used in digital comparators to determine the equality of two binary numbers. When the input to an XOR gate are equal, the output is low, which is 0. Hence, XOR gates are utilized for equality checking in various digital systems. Sixth one is addressing decoding in memory systems. XOR gates are employed in address decoding circuits for memory systems. They help specific memory location based on the address inputs. Introduction to Verilog as hardware description language. Verilog is a hardware description language used to model, stimulate, and synthesize digital circuit. It provides a means to describe the behavior and structure of electronic system at different levels of abstraction. Originally developed in the 1980s, Verilog has become an industry standard language for digital design and is widely used in the field of electronic design, automation, EDA. Key features of Verilog include consciousness and simplicity. Verilog allows designers to describe complex digital circuits with a concise and readable syntax, making it well suited for hardware description. Modularity. Designers can break down a system into smaller modular components using Verilog modules, which promotes reusability and easier debugging. Stimulation and verification. Verilog supports simulation, enabling designers to verify the functionality of their designs before actual hardware implementation. This aids in the identification or resolution of potential issues. Then the fourth one is Verilog is not just a simulation language, it is also used for synthesis. Synthesis tools convert Verilog code into netlists that represent the physical implementation of the design or programmable logic. Devices, PLDs, or application-specific integrated circuits, ASICs. Fifth one is concurrency. Verilog allows the description of concurrent processes, facilitating the modeling of parallelism in digital systems. Hierarchy. Design hierarchy is supported in Verilog, enabling the organization of complex systems into manageable and understandable structures. Purpose of implementing an exclusive OR, which is XOR gate, Verilog. Implementing an XOR gate in Verilog serves as a practical example to illustrate how to model digital circuits using the language. The XOR gate is basic and commonly used logic gate, making it suitable for introductory Verilog examples. Purpose includes first one is learning the basics. Designing an XOR gate in Verilog introduces beginners to fundamental constructs of the language, such as modules, inputs, outputs, and assignments. Understanding behavioral modeling. Implementing an XOR gate allows user to explore different modeling styles in Verilog, such as behavioral model using procedural statements. Third one is simulation and testing. Verilog simulation capabilities enable designers to test the functionality of their XOR gate implementation in a virtual environment before moving to hardware. Synthesis readiness. Once the XOR gate is designed and verified in Verilog, it can synthesize from a target hardware platform using EDA tools. This prepares the design for eventual implementation on FPGA and ASIC devices. The three different models of XOR gate is first one is data flow module. Here is the Verilog code for data flow module. Module XOR data flow. We have taken two inputs A and B and output as Y, and we have assigned the Y with A exponent B, and we have ended the module. This module is directly implemented the XOR operation using assign statement. The XOR operation, which is the exponent, is performed on input A and B, and the result is assigned to the output Y. The model is concise and resembles the mathematical expression of an XOR gate. Second one is the behavioral module. Here is the verilog code for the behavioral module. First, we have taken module XOR behavioral with two inputs A and B and output Y. And we have taken always begin Y is equal to A exponent B and an end module. This module uses behavioral approach with the always block, which is sensitive to all input changes. Inside the always block, XOR operation, which is the exponent, is performed on inputs A and B, and the result is assigned to the output Y. The behavioral model provides a procedural description of the XOR gate operation. Third one is the structural module, and here is the verilog code for the structural module. We have taken two inputs A and B and output Y at XOR gate with A of A, B of B, Y of Y and N module. And we have taken again A and B as input and output Y with the assigned value Y with A exponent B and N. The XOR structural module instantaneates the XOR gate module, creating a hierarchical design. The XOR gate module defines the XOR operation using the assign as statement, similar to the data flow model. The structural model allows for modular design by encapsulating the XOR gate functionality in a separate model XOR gate. Consideration for each Verilog model. First one is data flow model. Direct mapping maps directly to the mathematical expression, making it intuitive. Conciseness provides a concise and straightforward representation for simple logic. Readability easy to read and understand for basic combinational operation. Second one is behavioral model. Procedural approach utilizes the always block for procedural description. Flexibility suitable for more complex combinational logic with sequential behavior. Control offers better control over simulation and timing aspects. Third one is structural model. Modularity encourages modular design with a separate submodule for the XOR gate. Organization enhances readability and maintainability through hierarchical structuring. Scalability supports a divide and conquer approach for building larger systems. In conclusion, the Verilog model, data flow, behavioral, and structural each offer distinctive advantages tailored to varying design scenarios. The data flow model stands out for its simplicity and direct mapping of mathematical expressions, ideal for basic logic. The behavioral model introduces a procedural approach accommodating complexity, allowing finer control over sequential and combinational operations. Meanwhile, the structural module promotes modular design, enhancing scalability, organization, and collaboration within larger circuit. Ultimately, a thoughtful selection of the Verilog module is pivotal to the success of a design. It ensures that the chosen approach aligns seamlessly with the project's unique characteristic, facilitating a smooth development process and setting the stage for future expansion and collaboration. Thank you.